let's get started. Thanks for joining today. And then, first of all, so some people actually heard about that. We have some party tonight, Deborah Rocks. And then I got to bring some invitation ticket here. So if you feel free, grab some ticket and then go to the Deborah Rocks place. It's a 14 minutes away by walk from this venue and starting 6:45 p.m. So hopefully you guys stop by and then grab some beer and then some good food. Okay. So I give you some here, and then we already have some more invitation card in the Red Hat booth. Okay, so I'm going to talk a little bit about next 15-minute event-driven autoscaling for serverless Java application. So quick question, how many people actually have some experience deploy your Java application into serverless platform, aka Amazon, Google, Microsoft, things like that? Oh, pretty good. And then how many of them experience to finger on keyboard, Quarkus? Okay, not much, but I like that. And then one last question. How many people actually deploy your Java application into Kubernetes? Wow. You guys all deploy application Kubernetes in production? That's awesome. Okay. That's awesome. Okay. So who am I? My name is Daniel. I'm developer advocate and Red Hat. And also I got a bunch of stuff here. I pretty much spend a lot of time to bring more Java application into public cloud and then Kubernetes, aka hyperscalers, Amazon, Google, Microsoft. And then I focus on cloud native runtime, which is Spring Boot, Quarkus, and then a bunch of the JavaScript stuff. And I'm based on Boston in the United States. And then that's why whenever I came to the London, I feel some kind of commonality and similarity because we have Cambridge. And we have a very similar, like a Victoria, the building architecture, like a condo, an apartment, and a single family house. So when I arrived in Tuesday morning, unfortunately, I took the Uber, and then it took more than 2 hours from Heathrow Airport to get my hotel. But after that, I just gave it a try to walk around the city, and then I feel very comfortable because there's some apartment and condo, and then even street, like Arlington, and then it's pretty much similar in Boston. So if you have any chance to fly to the Boston, you feel very similar thing, just like me. Okay. So, and also I'm like a Java champion and then CNCF ambassador, and then which he allows me to spend a lot of time evangelize not only developers, but also platform engineer and architect, and then like IT ops people in terms of to bring more fancy cloud native architecture. Here's my contact information, like a Twitter, and YouTube channel, and then GitHub repository, and then my book, things like that. And then feel free to reach out to me around my skill set and then any technical question I'm happy to address. All right, so one quick slide before we getting into today's topic. So we, Red Hat, released Quarkus 3 last week. And then Quarkus 3, we bunch of the new feature, for example, the performance, we support Hibernate ORM 6.2. That a huge change compared to Hibernate ORM 5. So you are most likely a Spring developer, I pretty much assume, and then you pretty much use like a Spring JPA. But this is a Quarkus way. Quarkus uses Hibernate ORM with Panache to develop data transaction. And then Quarkus pretty much focuses on Kubernetes because Quarkus was born after Kubernetes, which means as long as you want to deploy your microservice application into Kubernetes, we support developer, how to make it easier. So for example, previously, traditionally, you just write a code and then testing code, push the code, that's it. Your job is done. However, Kubernetes changed your life. You need to verify your application as a containerization and the running on Kubernetes and then verify your functionality, capability, etc. And unless you don't want to fight your DevOps engineers. So even if, oh yeah, my application is perfect, I don't have any issue because I already developed my business application. However, in the midnight, your DevOps engineer or SRE just made a phone call to you. Hey, Dan, we got a situation. We just deploy your application using fantastic CI/CD pipeline, but we got some error. You should take a look at that right now. However, that's not possible because my source code is perfect, man. But that's not true. So that's why everybody wants to do some test-driven development, which is so boring. I know that. I've been there, done that. However, which means you spend more time to outer loop. However, if you could save your time during inner loop and then give some time into outer loop, that's Quarkus help you out. And then we have a bunch of like a dev services based on test container. But you may ask, hey, I can use that test container in the Spring Boot or Micronaut, highly done. Sure, go ahead. And the Quarkus actually provide that kind of capability out-of-box features, which means you don't need to add any kind of ecosystem and library or dependency or compilation. Quarkus just provided that feature. You can just use that. And there are more new fantastic feature coming out. For example, a lot of people are interested in virtual thread, like a project room. So Quarkus 3.2 is coming soon, like June or July. We're going to integrate into project room to develop the reactive programming based on virtual thread room, which is awesome as well. And also provide the Jacquard EE quote, like a 10. You don't need to find out Java X namespace packaging on your import. So you just only use Jacquard EE10. So feel free stop by Red Hat booth. We have many kind of live encoding show. Here's my colleague and my friend Kevin. He's going to showcase a very interesting demo today, right? And then this afternoon, Java is short, right? Yeah. That's all kind of the Quarkus 3 stuff. Okay, let's jump into our main topic today. So this is a very known and then general and then traditional autoscaling architecture on top of the Kubernetes. So one of the beauty of the Kubernetes is allows you just manage autoscaling depends on your network traffics. You don't need to care about that because Kubernetes take care of it for you. And then, so for example, here's an online application like inventory catalog and order and then payment. And then you just create a horizontal pod autoscaler, aka HEPA, and it will scale out your application based on CPU memory, things like that. So this is just some beauty of the Kubernetes autoscaling. However, in reality, that's not enough. As you can see, you have external services to autoscale your application, specifically event-driven application. So some of your application microservices, not only Java, maybe Python, .NET, because Kubernetes allows you to deploy any kind of application runtimes. And then one of your applications should be scaled out based on Kafka metric or Kafka messaging or event storing, or some of the applications scaled out based on metric-driven some data, like from Prometheus. Or you could deploy application like a public cloud, like Amazon or Microsoft. You need to monitor Amazon Cloud Watch or the Azure Monitor. So you cannot be sure. You just scale out your application based on CPU or memory utilization. It depends on some external services, specifically event-driven application. So how do you do that? So this is just some kind of common practice is how to make it better, your autoscaling infrastructure using Kubernetes custom metrics. As you can see, you can define like a AWS Cloud Watch metric adapter or a Prometheus metric adapter or like a custom metric for Azure Monitor. But there's no custom metric for specifically directly into Kafka cluster. And then the problem is you can only enable one of the custom metric at one time in the single namespace. So with that, so my project deploy multiple services on one namespace or like a project. And then you can only enable one of the external services to scale out your application. So that's not ideal design. So that's one of the reasons why KEDA project actually came out as a part of the CNCF project. It's just acronym. The Kubernetes event-driven autoscaling is super simple. You don't need to rewrite existing application. You don't need to rewrite Kubernetes manifesto, aka YAML file, which is a totally pain in the ass for developers. So you don't need to rewrite any kind of stuff. You just specify, okay, here is my target resources like a deployment. And then what is my trigger to scale out this application? That is, you can specify some new object, aka scaled object, scale batch job. And then, so Microsoft and the Red Hat spend a lot of time and invest this kind of project. And then you could have more than 60 built-in scaler to decide which metrics impact your auto scaling on your application side. For example, Kafka or Prometheus and RabbitMQ and then a bunch of the AWS and Azure services as well. You can install KEDA with the operator or some prepared way by developer like a Helm chart. So with the KEDA, we can redesign this auto-scaling application architecture based on Kubernetes. As you can see, we don't have any HPA anymore mapped to each application. However, we just create a scale object at the bottom, and then in the middle of the KEDA infrastructure, the one of the good good benefit of KEDA. So KEDA only actually managing scale 0 to 1, 1 to 0. However, it's one container, one application is not good enough for your maybe millions of application traffic for event-driven or event streaming. So that's why KEDA actually invoke existing HPA to scale out from 1 to maybe 1,000 or 1,000,000, depends on the incoming traffic. And then this is just some of the architecture, and then I don't need to spend a lot of time here. As you can see, the main purpose here, you can see here, so from 1 to 0, 0 to 1 is handled by basically KEDA. And then even if you have more incoming traffic after that, and then KEDA call existing Kubernetes HPA, Horizontal Pod Autoscaler, to scale out to more than 1. And then here's some example how to create the scaled object. I'm going to go into the demo and then actually showcase that specification. And then, so what about the serverless autoscaling? Because KEDA is not pure serverless, because you just deploy existing application. It's all the time running 24/7. And then when you just set up KEDA to that existing application container pod, and then each scale will be scaled down to 0, just like a serverless behavior. But at the very beginning, it's still running on all the time. So which means that we're not going to say 100% like a serverless, just like an Amazon Lambda. So what about we need to have deploy existing microservice application into Kubernetes and not Amazon Lambda for serverless capability? So Knative project to handle that kind of stuff. But whenever I talk about this topic, and many people ask me, hey, Dan, so you just talked about KEDA and Knative. It's a pretty much a similar name. Sometimes I'm also confused. And then, so here are just some bullet points. So what is the difference between KEDA versus Knative? So Knative, bottom line, you need to rewrite Kubernetes resources, aka YAML file, based on Knative services. You already deploy your application using Kubernetes deployment. However, you need to recreate the Knative service YAML file to deploy the same application to Kubernetes to have serverless capability. And also, Knative impact existing application directly, which means that we can push some approach. And then you can also rewrite existing application, not only Java, but also Python, Go, .NET, etc. Because you need to handle Knative eventing for event-driven application. However, on the other hand, Knative, you don't need to change anything, super simple, but you're not going to handle 100% pure serverless application. Also, Knative also has their own autoscaler, Knative not using HPA by default. So I'm gonna showcase 3 different demos today. Hopefully Wi-Fi is stable. I'm gonna try to set it up the Wi-Fi with many different options, hotspot my mobile phone and my friend Kevin's mobile, and they even hear hard wire, but it's not good. So anyway, so finger crossed. So for example, so we're gonna keep evolving existing event-driven application architecture. First of all, this is not event-driven, but this example showcases what is the potential issue when you use Kubernetes HPA for your event-driven application. I'm going to try to use a Java application based on Quarkus, but this architecture, you can use any kind of Java application, Spring Boot, Micronaut, or even traditional EJB if you want, and then like a Halidon. But the reason why I'm going to use Quarkus, I'm going to explain a little bit later. Okay, let's get into the demo environment. So here's my Kubernetes cluster, which is a Red Hat the OpenShift sandbox. You can go to developers at redhat.com. If you already have some chance to stop by our booth, the Kevin already mentioned about this. So developers at redhat.com, you can actually start developer sandbox, and then you can use and you can sign up for free with some your identification verification with your email address or your text message via your mobile phone, and we can give you a free OpenShift cluster for 30 days. And after that, you can resubmit, and we can give you another 30 days. It's not only Kubernetes cluster, but also we give you some bunch of the tutorial, like a video and the documentation, and then ebook, and then like a chit chat, and there are many kind of stuff. And then I already installed the Kafka cluster, and then Jupyter for HA stuff, and then I already installed Knative and the KEDA as well. So here's the first project. So Kafka HPA. So there is no application at this moment. This is just my Kafka cluster. And here's my simple sample application. I have 2 applications. One is Quarkus, and then this is we actually released Quarkus 303 yesterday. And then the Quarkus upstream, we typically release a new minor version bi-weekly, like every 2 weeks. It's super fast, right? And then we have a bunch of stuff in Quarkus 3, just so I mentioned earlier. And then this is a very simple application. When I go to like a sample application here, just event application. And so this is the first reason why I want to use Quarkus today. So Quarkus was built on the reactive engine, which is BirdX and Netty. And then if you have some experience to develop reactive programming based on like for example, Spring Boot, you need to rewrite existing Spring Boot application into Spring Reactive with a bunch of the ecosystem like a Spring integration or Spring Cloud or even sometimes Spring Functions. It's not the same anymore, not apples to apple. It's like apples and pineapple. So you need to rewrite every single detail. It's a totally challenging. Yeah, I've been there, done that. And then also, a lot of people wanted to consume like a Kafka cluster as a backend server. How to send my messaging to like a JSON format message in the Kafka cluster. How to consume it. And then you need to also put in the like a mono webhooks, things like that, and then you can have some create your own custom channel, and then you can also create a Kafka consumer class instance, and you can also use like a Docker file to like a Docker compose file to running a local Kafka cluster on your local machine to verify your application functionality. So Quarkus actually built on reactive engine, which allows you to very easily develop reactive programming, but also you can also develop non-reactive programming at the same time. You don't need to rewrite your whole bunch of the application code. Just the only thing you need to do, just use relevant Quarkus extension. You can say like a maybe dependency or a gradual module, and then you can add the relevant annotation. For example, here, annotation incoming, and this is my topic name on top of the Kafka cluster. With this annotation, this method automatically treated by like a reactive programming by Quarkus. If you put in the like some annotation path, like for RESTful API. And then Quarkus treats this application and method and class as a non-reactive application. And then this is an incoming means I'm going to consume from my dash topic from Kafka cluster and then process a JSON format. If you set it up like an outgoing annotation, which means I'm going to sending my message into Kafka cluster or a messaging broker or AWS like a messaging services, things like that. That's it, and that's the one of the reason why. And then when you go to like an application property, okay, you can use the application YAML file. You can prepare to YAML format, and then here's a bunch of the compilation. Where is the point? Is where my Bootstrap server here? This is my Bootstrap server, but I don't have any IP address here. This is like some not fully qualified domain name, but it's the actual Kubernetes service name. As I mentioned earlier, I already deployed to Kubernetes at Kafka cluster. And then here's just some deserialization and serialize some option. And then here's another reason why I use Quarkus today. So when you finish your application coding, and then what is the next step to verify your application function into Kubernetes? You need to containerize your application. How do you do that? You just need to use some CLI, like some Docker CLI, Podman CLI, whatever you need, like some create a Docker file and then containerize your application on your local, and then push that image into somewhere container registry, like a KEDA.io, Docker Hub, or Google Container Registry, or your private company container registry. And what about next step? Okay, I need to create a YAML file to reporting that container image registry and will fully qualify domain name, and then bunch of the Kubernetes manifest like a services or ingress router, and then bunch of the other configuration and specification. And then you're going to run kubectl to apply that resource to create in your available worker node. And then Kubernetes figure out, okay, this is available worker. I'm going to pull container image down into that worker, and they're just running on. So this is a multiple step, we can say out of loop process as a developer life. And the Quarkus actually provides some nice feature extension, like a Kubernetes extension or OpenShift extension. It allows to automatically generate Docker file or Kubernetes YAML file, and then even if you don't need to run Docker CLI kubectl, it's automatically generate that file and run it into Kubernetes cluster as long as you already have container runtime environment, like such as Docker, and then you already log in the remote Kubernetes cluster. So I just needed a few configuration here. I'm going to deploy this application Kubernetes in the target environment, OpenShift. You can say Knative for serverless, or you can say Kubernetes, like any kind of Kubernetes. And then, so OpenShift cluster provide TLS termination for HTTPS protocol for security. And then based on it, use the just open source certificate. So that's why I'm going to make sure I'm going to use that certificate. And then you can also set it up multiple container build strategy, like a Docker or a Podman or a build pack or one of the feature of OpenShift, the source to image process, things like that. So this is the second reason I do that. So let me try to go to terminal window, and then I'm going to try to exit my project, Kafka HPA. I'm going to use Quarkus here. You can actually use Maven and Gradle, but this is a Maven project, which means you can use Maven command line, such as a Maven clean install or clean package, which automatically, when you go back to my project and then go to target directory, and it automatically generates Kubernetes directory, and then you can see OpenShift YAML. When you set it up target Knative, it generates Knative YAML. When you set it up Kubernetes as a target environment, it generates Kubernetes YAML or JSON. And then when you open the OpenShift YAML, you can see a bunch of the resources like services, and then image stream, which is some kind of metadata for actual image, and then like a build configuration, and then like a deployment configuration. And then there are more detail, like a resource limit request for autoscaling, things like that. So, and also when you generate new Quarkus project, the Docker file automatically generate both JVM, but also native compilation. So Quarkus actually provide two different compilation strategy. One is just in time, the other one is ahead of time strategy. So when you go to just in time running on JVM with some jar file, the Quarkus says fast jar because your Quarkus override class loader, and then which makes Quarkus the application Java a little bit faster than any other Java frame, such as Uber or ThinJar. And then you can also have a native executable running on GraalVM rather than JVM. It's just an executable file, just like some exe extension file on Windows operating system. And then if you still consider about like a tiny container image, and then Quarkus actually provide here so micro base image. And then also legacy jar, which is like a Uber jar, it automatically create the runnable Java file under target directory. But Quarkus typically create the Java file not right under target, it's under the target slash Quarkus dash application. So in case your learning platform just referring to some jar file right under target directory rather than two level depths, with that you need to use the legacy jar Docker file, and then Quarkus provide some configuration key and value like a quarkus.package.type, and then you can set it up like a legacy jar. It automatically generates jar file right under target directory. So that's it. Okay. Oh, it's done, man. I tried this one for the session, but it never ends. Yay! Okay, I'm so happy for that. Okay, so this is a Quarkus application right now, the fancy UI. I like that. And then can I go to VRox? And then as you can see, I just connect to my Kafka topic. Name is my dash topic. And then here's the Quarkus 3.3 version. And then it starts like a 5 second, and a bunch of the extension capability I already enable, like a Jackson, Kubernetes, and Kafka, things like that. And then when I go back to topology view, and then here's the detail, and then I can actually up and down my application, like a scale up and down, which is not auto scaling. So that's why I'm going to go back to here. I'm going to set it up auto scaling, my application min-max 10, and the percentage is 70%, the CPU utilization. And then now you can see auto scaling is set it up. And also go to HPA, just like a target 70%, which means the HPA keep looking at the CPU utilization. It reached to 70% utilization. It's now time to scale out. Okay, so how do we scale out on the performance test? Luckily, the Kafka cluster actually include the performance test bash script inside the Kafka cluster, which is under the Win directory, Kafka plus the performance test. With that, I'm gonna just create a dummy record and 1 million record and the five parallel process every single second here. And then I just run this YAML file. You can run the kubectl, or you can use like a nice GUI if you prefer GUI. I prefer GUI. And then back to the topology view. And then application here, the 5, just here, the 5 pod is running. When you go into inside the pod, now you can see the record is just sent to Kafka topic. It's literally created every single second, but it's rendering, it takes a little bit more time, but it's literally inside, it's 1 second. And then back to the application, but nothing happened. But when I'm looking at the Quarkus, what are you doing right now? I'm so crazy busy, man. As you can see, I'm processing next to 5 million the record, and then it's totally make me crazy. And then, but the Kubernetes HPA, hey, take it easy, man. I gotta take some time to figure out when you actually scale up. I would say it's some little bit idiot thing and stupid Kubernetes. So that's the thing, the problem in the Kubernetes with the HPA. So now I'm gonna try to redesign this application in the case 2. So case 2 we're going to use KEDA to redesign this kind of thing. As you can see, right-hand side, we now have a KEDA. And the KEDA actually keep monitoring and scraping all metric data from Kafka cluster directly. In the meantime, our Quarkus application actually consumed the messaging. He's doing their own job. And then in the sometime later, the Knative made a decision, okay, it's the right time to scale out your application. So let's go into the demo environment and I'll change my new project, the Kafka KEDA. And then here's a Kafka cluster and then no application at this moment. And then, so here's my application. Maybe this is another way to deploy application, just running like a YAML file. And then it's just like my application. And then the packaging is the application, push it into container registry, just like your traditional practice. And then here's my Bootstrap server, my environment variable. And I just create this application. And then back to here. The Quarkus application is running. And then once it's run, and I needed to create the Kafka scale, the scaled object for Knative object. As you can see, what is my target? Here is a target, is a Quarkus-EDA-demo, which is this deployment name, same name here. And when you go to Quarkus stat, and then you can see Kafka topic enabled, and then the same version here, 303. And then just make sure I'm going to use the same application. I'm not going to try to cheat on this kind of performance result. And then back to here. And then what is a trigger? As you can see, the Kafka is my trigger to scale up for KEDA. So that's why I would say this is a very simple. And then I'm going to try to create scale object, which allows me is automatically set it up autoscaling status. And also you can see HPA automatically is created by KEDA. I don't even create the HPA just like I did in the first namespace. And then back to here. And let's try to use the same performance bash script and then give it some try to what happened in there. And then back to topology view. And then it creates 5 different paths and then generate the dummy record for the next couple of minutes, 5 million. And then this is my Quarkus application. And then when you go to that, as you can see, it's really scaled out to 4. It's really fast. And then this is, so KEDA, that's exactly people really like that for event-driven application. Because it's not waiting for like a CPU realization. It's really monitoring the events storming and streaming, and decide, okay, this is the right time because for your Quarkus application going crazy, right? So when you go back to the previous namespace, and then your job is done, which means the 5 million data is just created on Kafka cluster, and now you can see just 2 applications scale out based on stupid HPA, right? And then when you go to Quarkus stuff, and then it's going crazy, man. So back to the application, and then go to HPA, what happened in there? So HPA is say 70%, and after exceed 70%, it's increased 2 container, and then it's a little bit sliding down to like 44%. But in reality, the Quarkus is crazy busy to process 5 million. So maybe half 250 million, 2.5 million. So that's not even just 2 parts. So, and then back to the KEDA, and now you can see that the application, here we go, is scaled to 10, just like a maximum. So you can actually set it up like a maximum 100 or 1,000 as long as your Kubernetes cluster allows the resources. So that's the one of the evidence why KEDA would be better for event-driven application, but not 100% serverless. So let's go to serverless part. So this is a Knative stuff, just like I mentioned. So okay, if you just choose Knative rather than KEDA for serverless for event-driven application, as you can see, our architecture a little bit changed that. We don't have any KEDA here. However, we have a Knative. And Knative, you need to rewrite your application, but also create a new YAML file, Kubernetes resources, and then there are Knative eventing infrastructure, which is one of the component Knative project. This some kind of middle layer, like a liaison between like external services and your application. So previously, the Kafka messaging can be consuming directly to application. However, now you can see that Kafka source is an eventing infrastructure, just get the messaging and then pass through to application, not directly. And so let's go to what it looks like. And then moving to the another project, Kafka Knative. And then I'm going to change the project here, Kafka Knative. And then back to my application. So let me change my another application here. And then first of all, when I go to my application, so now you can see that it's a little bit changey handling cloud event. But this application, there is no business logic at this moment. That's why I just print out the messaging logo. However, if you have some the business logic here, you need to rewrite your application to handle cloud events. So cloud event is a brand new standard, the messaging format across multiple the sending messaging and pops up server. For example, some application format, you're going to use the JSON format. Some application using like a binary. The other application may be using protobuf. How to transfer among the other like a format. So cloud event actually gives some standard messaging format across that different messaging infrastructure for serverless application. So, and also, when I go to application property, and now I'm going to set a target for Knative, previously OpenShift, and then here is some bunch of the configuration exactly same. But now I can see that you cannot see that here is a Kafka configuration. Previously, when I go to previous configuration, you can see here's all Kafka configuration, but now you don't see that. Here, you don't see that, the Kafka stuff, because we're going to create Kafka source, which is another rewrite YAML file to liaison between our Kafka cluster here, Bootstrap server, and the topic name. And then what is the sync source? What is the consuming application, which is a Knative service name here. So let me try go back to here and then try to build once again and deploy application. So Quarkus build command line is actually packaging job file first, like a thin jar, like a fast jar, and then you can also use Native compilation as well if you want. And then next step, we're going to containerize this application using Docker file or OpenShift source to image processor. And then after that, the container image will be pushed into OpenShift container integrate registry based on like a quay.io. And then with the Quarkus command line, and then also call the Kubernetes API, like just you're going to use the kubectl API command line on your local machine. There's multiple steps just happening when I just run Quarkus CLI, or even you can use the Maven command line or Maven clean packaging. It allows to skip all kind of steps manually by developer. The Quarkus framework do to that for developers. Okay, it's gonna be take some time, and then once we create that, and we're gonna create Kafka source here, and then let me go back to terminal. Okay, it takes a little bit more time. So once we deploy, and then we're going to create the Kafka source, which we connect to between application and then our serverless application and Kafka topic. And then we're going to run the same Kafka performance batch script, and then take a look at that, how much longer we need to waiting for scale out. But we give some time to scale down to 0, that application first. So Knative by default configuration scale down to 0 will be 30 seconds. You can actually reset like maybe 5 minutes or 10 minutes based on your expectation. And then once they scale down to 0 without any kind of natural traffic, and then we're gonna call that application like using RESTful API or some incoming messaging from Kafka, and then it automatically scale out just like Amazon Lambda or Azure Functions. And then there are a bunch of the steps like a Docker file and things like that. And then it's gonna be almost done, and then publishing that. So just in FYI, so when I just run this application demo on my like at home, Boston, not here, it just takes less than 1 minute. But now we more than 2 minutes. Okay, I gotta change it here. Okay, so the application, and then I'm gonna try to create Kafka source, and then you can see that my Kafka source here. Here on the ED8. Oh my God! I actually needed to change my application. Oh my! So I wasted 2 minutes for that. Oh my! Okay, let me try to delete the application, the cleaned up, just in case to conflict some of stuff here. Okay. So we still have 9 minutes today. Hopefully I can finish my talk. Yeah, gonna be exciting. Okay, back to here. And then, all right. So one more time, deploy application. So it actually, when you deploy this application in OpenShift cluster in a developer topology view, the icon is slightly different. So previously it's just circle eyeball candy style, but now it's some like a rectangle, and then it's obviously, oh, this is a serverless application on Kubernetes. And then you obviously figure out, oh, this application serverless, or this application just a normal pod, which we are running 24/7. And then once the application running on here, and then it automatically attach that, and then we're gonna run the same performance test. And then in the meantime, let me try to go back to slide deck and then just explain what is our target and the goal today. So what about the event-driven serverless autoscaling? How do we have some benefit from KEDA as well as Knative? Because I mentioned earlier, a lot of developers ask me, hey Dan, so which one should I choose, Knative or KEDA? And then I would say, yeah, it depends on your some expectation and your experience on Kubernetes, and also you are more focused on event-driven application or non-reactive application. But things change that. We have a new sandbox project which integrates KEDA and Knative. So now you have both benefit from now on. So Knative, KEDA actually auto-scale Knative eventing infrastructure, which is in our demo, is Kafka source. And also, you can actually set up a bunch of the process. So for example, previously KEDA actually only scale out application. It takes some time to scale out 4 and then scale 10. It takes a couple, maybe 10 seconds or 15 seconds. However, KEDA, Knative with this architecture will be complicated. However, so KEDA actually keep consuming data from Kafka and then just impact to Knative eventing, which is just a multiple process scale out. And in the meantime, it called KEDA and the Knative, sorry about that. And the Knative actually scale out application itself. So two areas scale out simultaneously. That's why it's more flexible, dynamically, and faster scale out. And also keep monitoring the actual processing inside the application, which is you already job done, it's automatically scale in. So pretty much dynamically still. In the end, your ops people will be happy for that because it saves you money, time, etc. Okay, so back to the terminal. Hopefully it's done. Okay, Finally it's done. And then here we go. Okay, now you can see it's attached here. And then it will scan to down to 0. The same application, 303. And then it says the Quarkus app. It will scan down to 0. In the meantime, let me try to make sure this application is just Quarkus and not Spring Boot. No offense. Runtime, Quarkus. Okay, and then it will scale down to 0 in next couple of seconds. And as you can see, it's terminating right now. And then because it's a little bit keep tracking some trend, just not killing it, because you keep monitor. Okay, so 10 seconds, no traffic. 30 seconds ago, no traffic. And now, okay, 1 minute ago, no traffic. Okay, now I'm going to make a decision. Now it's time to scale down to 0. And then I go back to my application in the job here, once again. And then once it is scaled down to 0, and then now there's no application, just 0 here. Then create to XML, the YAML file. And then it automatically created like 5 different processes in which he generated a dummy record, like a 5 million. And then now you can see the application scale out automatically, just like an Amazon Lambda, based on cold start strategy. And then there is no way scale out to more than one application. That's just some limitation on Knative for serverless and event-driven application. That's why we're going to go to KEDA Knative new project. And then I'm going to make sure to change my project once again. KEDA and Knative. And also, I need to change my application property. So here is the container image group, which is actual namespace. So I need to change the namespace. And then here is some compilation for Knative. This is a third reason I wanted to use Quarkus for Knative project, because I just set up Knative stuff here, which allows me, rather than just creating YAML file directly, when I set up this key and value compilation more Java programmatically way, and then it generate YAML file. And I just save that, and I'm back to the terminal, and I'm going to try to build once again. And also, previously we actually deployed Knative. That's why when I go to Kubernetes directory, now you can see Knative YAML and JSON file. So that's the reason why, another like a fourth reason why I have to use Quarkus today. I don't need to create the YAML file for Knative. Previously, even if I have Kubernetes YAML file for normal application, but one day my manager, hey Dan, you need to deploy your existing application to Kubernetes with the like a Knative for serverless functionality. Okay, how do I do that? Okay, I needed to run how to rewrite Knative YAML file, which is another challenge for me. And then, so this is you just use Maven command line or Quarkus CLI. It's automatically create the Knative stuff. So which is one of a good example. And also we're going to create a new Kafka source again here. But this is a Kafka source based on that KEDA Knative integration project. Now you can set it up annotation for KEDA. So this is a KEDA and Knative annotation allows KEDA actually call Knative to autoscale more than one container application. Previously, when I go back to just copy in that case, and then go back to here, and then back to the Kafka Knative project, and then you can still see that the application just one, not 10. It never ever scaled out to 10. That is a limitation Knative. And then just in case, when you go back to HPA project, job is done, and then the application still one. It takes some time to digest 5 million. However, when I go to KEDA, and it's also job's done, and the job is done with the 10 application, and now its application scaled down to 0, just like a KEDA feature. It's now, from now on, this application, very similar serverless, but that's why I mentioned earlier, not 100% serverless stuff. And then go back to last project, and then terminal, okay. different demo video. Oh, it's coming back. Okay. So for demo video, just like a full use case on my YouTube channel. So you can go here, the bit.ly URL, Daniel TV, and then subscribe, and then watching that video, and then you can give me any feedback. Okay, this is cool, this is bad, or I'm really looking forward to some kind of tutorial, and then just put on the comment. I'm more than happy to create some bunch of the demo for you guys, and then feel free to reach out to me any kind of question by the YouTube channel and the Twitter. And then if you feel more interesting Quarkus stuff, here's our bunch of the contact information, Julep chat, and then official website, and then like a GitHub stuff, things like that. Thanks for coming today, and enjoy the rest of the DevOps. Thank you. Oh yeah, it's almost done.